Hey guys, what's up? Coming at you with a report here. So we're just going to kind of jump into it. Just want to say thanks to everybody that's here and listening to me, and thanks for everybody supporting me. I really appreciate it, guys. Never expected, always appreciated. Okay, so thank you guys. Anybody that's been supporting me, I'm still adding names to the list so I can give you guys some recognition. So check out my PayPal link there in the description. It's down there, and so is my P.O. box for people that don't want to do the electronic thing. It is appreciated, so thank you. And we'll move on. Now, we're starting here with the Schumann. We got the 20 hertz is there. What is the Schumann? It's the vibration of the Earth between the surface and our ionosphere. Okay? They have to put this 783, the Schumann resonance here. They actually use it in the space station and people that work underground. Why? Because if it's not there, they start having mental health issues. Very well documented, something that does happen. Now, you'll get ringing in your ears when you see a big spike on here too. A lot of people are more sensitive to this than others. It can cause headaches, it can cause heart issues, all kinds of bad things, right? But it can do good things too, but we're not, what I'm saying here is don't neglect going to the doctor, okay? Please don't. Rule out the physical part first, and then take this to your doctor. They're starting to accept this stuff a lot more than what they used to. 10 years ago, you got looked at like you were crazy. Now we have big name doctors and stuff using this to diagnose people, and at least help them diagnose people and do surgeries and stuff at specific times because of this. Alright? So understand that. So yes, this touches everything. This is everything. So when this thing starts getting all jacked up, we got to understand that SHTF is, you know, around the corner. But that's just what we're talking about, right? So anyway, just don't neglect going to the doctor, guys. Please. Solar wind. Solar X-ray flux is what we're looking at here. This is what we look at for solar flares. We've had some small flaring. This one here, I'm not sure if it got into C class or not, but regardless, no big deal there. Proton flux, that is radiation storm stuff that we look at. Astronauts and people that fly are more prone to this, but this thing ain't moving at all. We haven't seen it move a whole lot in quite some time. About a month or so ago, we seen a big uptick in this. It almost got into storm level, if I remember correctly, but it was after a big flare. Okay, so that's typically when we see these things. Geomagnetic activity. This is what we really get concerned with most of the time. Okay, you're looking at solar wind impacts, CME impacts, all that kind of stuff, right? So a KP is really hanging right around 2 or 3 right here is really normal. Now we were expecting a solar wind stream to hit us on the 25th, and it's here. Just so you know, that's why these bars are up this far. If you remember my live stream from last night, if you listened to it then, thank you for listening. But I said, because when I did the live stream, this bar was there, and I said, well, it'll be interesting to see what it does the next bar, because I started seeing this small little uptick at that particular time. Well, what happened was it actually went down, so that kind of surprised me. But then the next one came in and it was all the way up to a 4. So that's one KP number away from a geomagnetic storm. Now, what do we expect during a geomagnetic storm? Well, not a whole lot. Just uptick in aurora. Sometimes we'll see an uptick in earthquakes, intensity, and excuse me, amount of them. So here's NOAA's predictions. Okay, 2 and 3. That's telling you the KP number. That would have been here. 2, 3, right? So they're pretty close there. Then we go up here and it says 3, 2. Well, it went 3, 1. But the next one's a 1, right? Well, we're at a 4 and a 4. So what does that mean? Well, I think because if you look down here, they got this thing kind of going up again down here. I think they thought this might have been coming in here. So the solar wind stream got here faster than what they thought, which is actually why it is stronger. It's moving faster. It's hitting us harder because of the speed. All right. How do I know that? Well, because here, this is the wind speed, solar wind speed. And the range is 300 to 600. Normal solar wind stream would be, solar wind speed would be 300 to 500 kilometers per second. Obviously, we've got above that. Now, this is the density. That should be hanging right around 4. Anything above that would be elevated. Now, I'm looking at this, guys, and I think what we're seeing is because I'm asking myself, you know, are we going to see a downtick here in the next one? Who knows? But I'm looking at this because we had a pretty good drop off right here, right, on both. But then it upticked real fast again. So I'm wondering if it wasn't just like a lull period, and it'll be interesting again to see if this actually gets into storm level. If it does, I'll let you guys know. If not, you know, I'm going to move on because, you know, G1 storms really, like I said, don't do much but give us increased aurora and possibly add to the earthquake number and intensity. So this is Enlil. All right, this is NOAA's prediction model. This is a top-down view. These are side views. This is the sun. That's Earth. This is stereo A. Same thing down here, guys. Sun, Earth, Sun, Earth. Now the top part of this graph shows you density. Remember, 4 is normal, so we're right here in time. This gives us 2 days behind us, and it tries to forecast 5 days out in advance. So they're forecasting us to not really have that much activity density-wise or speed-wise. See? Remember, 300 to 500 is normal, all within normal parameters here. But notice stereo A. You see this hump? Why are we seeing that hump? Because a lot of times when we see the hump on stereo A, about a day or two later, this model will show a hump at Earth. Well, the reason is because stereo A is here and things spiral this direction. See that? So whatever is affecting stereo A, a lot of times will affect us a couple days later. Especially if it's from a coronal hole or maybe even a CME, that kind of thing. That's why that does that. But also, there's a NASA model. It's the CME tracker, right? This model, this is from NOAA. So it's much like a hurricane prediction model. You remember the spaghetti lines you see during a hurricane, like on the Weather Channel? There's like 20 or 30 of them. They put those spaghetti string models all together on one graphic and they show it to you. What they're doing is they're showing you the different predictions from each model. Now, the models are getting the same data. What's different is the model itself and its parameters. And that's exactly the case right here with NOAA versus what we see from NASA. Now, NASA's model hasn't updated since the 8th, so I'm not even going to show it to you today, but that's what we're seeing there. Now, the magnometers, it started to jack around here a little bit when we seen that uptick, and that's exactly what we'd expect to see. This here is that one flare that I showed you up here. This one here. It could have gotten into C class, but if it did, still not a big deal. Remember, X-rays are here and gone in 8 minutes. We get more concerned about the CME that sometimes accompanies a solar flare, and it takes it, anywhere between 3 to 5 days to get here. So we got some time to look and analyze that. But just know that that's what's going on with that. Now here, like I said, that's that little flare. It didn't even do hardly anything or last very long. See that? That's all you seen was a little blink on this. So, no biggie. But I didn't want to show that to you. Magnetopause. Let me hit refresh on this and see what we get. So this is speed. And you're seeing little waves come in, right? And that's exactly what we'd expect to see. Now the reds are the higher speed. The yellows are lower. Our bow shock is out here. Okay, it's the point where our solar wind meets our magnetic field. That's all the bow shock is. It's our first line of defense. Notice there on the end, things started changing on that time lapse. It's because I think the reason why is because of this uptick here. Okay? So let's go back here. This is density. Alright, notice what's going on here. Remember the backward C shape that I was talking about out here in the front of us? Remember that? I was talking about it yesterday. I think it's a weak spot in our magnetic field. So if I keep moving like this, what are we going to see? So the white is low density, and the blue, the darker blues, are higher dense material. Now down here you're seeing pressure. Notice how the pressure is actually getting really close to our planet. Alright? Yeah. So this is kind of like the Earth acts like a capacitor. And how I would explain this is, if you take a firecracker or a stick of dynamite with a slow fuse on it, you light it. Well, that's the same as day after day after day of us being exposed to space weather. We kind of start collecting that energy, right? And a capacitor, once it gets so full, it has to release it. It has no choice. So what happens is, when the Earth, keeps day after day of retaining some of that energy, it has to let it go at some point. So it'll discharge in all directions sometimes. We see that. But when it's doing this at the same time, sometimes it happens when we're getting a solar event, a space weather event, like solar wind uptick. Because sometimes that's the straw that breaks the camel's back. So when we release it, it's much like that stick of dynamite or firecracker blowing. So it's kind of the same thing. I know the analogy is kind of strange there, but I think it helps people understand that, we build energy and then we have to let it go at some point. We don't have a choice. But this right here, definitely, and when we let it go, that's probably when it affects us having earthquakes, because we're pushing out. And so that's what happens. But I also want to show you this. I showed you guys this in my live stream last night, but I'm going to show it to you again. This is back on the 18th, and this is going to show you what I think is probably a weak spot in our magnetic field. Right here. Now here's our bow shock. How do I know it's our bow shock? Because the density is different drastically from one side to the other. Now the bow shock was always there. The only difference is we're getting some solar wind right here, and it's just showing up. That's why, because the density on one side is different than the other. But here, look at that. Okay, yeah. So when we see that backward C shape, we're seeing a little bit of this, and it's, like I said, it's right out in front. So I do think that's probably a weak spot, because there's more dense material there. Particles. What would allow more particles to come in? A crack, right? So we know our magnetic field is about 25% weaker than what it was. So what's that mean? Well, it just means that it doesn't take as much to give us a hit. So there's your update on that. Now, this is the Australian model. Remember, density, wind speed, this is the BZ. -6 is what we look for on the BZ or more. And that means the angle of the solar wind, which is what the BZ is favorable for it to come into our system. -6 or bigger. Now, if it's in the positive or whatever, that means the angle isn't quite right for it to have an easier time of getting to us. Sorry, excuse me, guys. But again, the density here is the normal density is 4. The wind speed is 3 to 500. So I'm going to play this, and you're going to see it bounce around, and the main reason is because the density is jumping from real low to high, and even the wind speed, you can see it getting over 500 up here. Okay, so that's why we're seeing the hits on our magnetopause. Alright, this here is just another magnetopause model. It's on, the sun's off to the right on this one, but we're seeing similar things. Okay, so I'm not really going to waste much time showing you guys this. I show this to you all the time, but it does, it does show us taking the solar wind hit, right? geoelectric field model. Guys, this is our space weather's effect on unnatural electrical components like transformers and wires. So what are we seeing here? Well, we're seeing a geomagnetic hit. That's what we're seeing, the solar wind. So if I push play, what are we going to see? Well, you know, when you look at millivolts here, typically it hangs around 2, 3, maybe 4. You're going to see this thing jump up into the 20s here on the end. So that means that we're definitely taking a hit. We'll wait for it to get to the end here. See that? Went to 22, right? So, yeah. So that's that. Now, aurora. That's the other way we can tell if we're getting space weather. South pole on the right, North pole on the left. Look what happened here. Okay, you definitely see an uptick here. Alaska, northern Canada, all these places probably seen some pretty great aurora. Notice how it got down to like almost the border of the United States. It probably crept over. So we were probably seeing some aurora down here in the States. South Pole, very similar. Okay, this is New Zealand over here, and it got, you know, the Borealis got into New Zealand. It almost got into Australia. So yeah, I think that's pretty interesting. So there's your North and South Pole. Seeds. Now, Seeds hasn't had any data come in from Stereo A, which is probably not that big of a deal. But what I will show you here is the fact that, excuse me, that it's not coming in on over here on ISWA either. So whatever the issue is, it's coming from the source, which would be the satellite or the station that receives the data, right? So we're just gonna have to wait and see what happens when that data gets put back in there and see what we see. You know what I mean? Hopefully there isn't corrupted data to where we can't even look at it because it's so wrong or whatever. Who knows? It would be nice to kind of look at that. So, spaceweather.com. Here's those aurora. They had like this mist, this green mist, and it was aurora up here, and they were out here in the ocean, and this is ocean spray, but it's being lit by the Borealis. That's pretty cool. That's green ocean spray. I thought that was awesome. Okay, here it says the solar wind has arrived. See, they're saying the same thing over here at spaceweather.com. You guys need to go give these guys some love. They do a really good job, so please go over and check out their website. Last night during my live stream, you know, we had 2798 sunspot on here. Well, it's gone. Remember I said it didn't look like it was there anymore? It wasn't, because they took it off. So now we only got 2 hanging out right here. This is an active area. It doesn't look like it's a spot yet, but it could turn into one at any time. I've seen solar wind, not solar wind, but sunspots pop up within just a couple hours, do a flare or a CME, and then disappear again within like 6 hours. Kind of crazy how fast that can happen. Earthquakes. Okay, let me hit reset on this. Now again, this is one of our main indicators, right? This is you know, this directly affects us really quick like. So if we're looking at this, you're seeing decent sized quakes. Okay, 4s or above. That was a 5.2. That was a 5.2. That was a 5. And then we had one down here in the Virgin Islands, guys. Those of us that live in the States, this is, you know, closer to us, and that's significant. Okay, now we can look at the bars here, and we'll go to the pager tab, and they're not showing any fatalities or anything, most likely not anyway, but you can kind of see where things are at. It happened out over the water, which is a good thing most of the time, unless it's big enough to cause a tsunami. Now this didn't, so that's what's good about it, because it wasn't where a bunch of populated areas are, because that's when we start seeing fatalities and stuff. So yeah, so I'll put on all magnitudes here just for a second, just to see where all the activity actually is, because we'll see the smaller ones too. And you can definitely see it swarming up here still, here on the west coast. Now this was over here in Alaska. That was a 5.1. out here in the Aleutian island chain. So that's pretty significant for up there. We can zoom in here a little bit and you can see the other. These are probably directly related to this one. Things were moving down there, so we're starting to see more and more earthquakes right here in this little spot. Now that's the New Madrid fault, okay? So things are starting to move there too. They have been for quite some time, but it seems to be getting more and more active. Most of this stuff over here in Oklahoma and Texas is usually fracking operations. If you don't know what that is, go check it out. Just research fracking. It's easy to find the information on that and what that is. So yeah. So I do think what we're going to have to do, guys, is keep an eye on this and see what's going on with that. And again, guys, you know, aurora is probably going to be the biggest thing we see from it. Again, maybe an uptick in earthquake activity. Now again, look here. See, we've had an uptick again here in solar wind speed and density, just as I'm doing this video. So we could still be getting that solar wind stream, and it could be getting intensified again. So we could get into storm level. I don't know. But we're just going to have to wait and see, guys. But anyway, guys, no negativity, no fear. Stay strong. Hope you guys have a good day. I'll see you guys later on tonight with my live stream. And yeah, and I'll give another report tomorrow morning. So God bless. Yahusha saves, and you can drink this Kool-Aid.